On this example, I'm going to start by graphing it. So let's just type in -5 divided by parentheses x minus 4. Graph. Now you'll notice some things. It looks like something's going on at over here somewhere around 4. If you go to the table, second graph, you'll see at 4 we have an error. So that's telling me is that it doesn't exist at x equals 4. So that tells me that my domain is going to be everything left to right except for the number 4, x value 4. So it goes forever to negative infinity, doesn't get to 4 until you use a parentheses, jumps over it, takes off again, but not from 4, but as close as we can get to 4, then goes to positive infinity. And that also tells me that my vertical asymptote is x equals 4. That's what that tells me. Now if you want to find it by hand, all you would do is take the x minus 4, which is the denominator, set that equals 0 and solve. And you get x equals 4. That tells you that when you have 4 on the bottom for x, you have division by 0, which you can't do, so the 4 doesn't exist. That's why it's not in the domain. And that's also how you find the vertical asymptote. But we just did it in the graphing calculator. Now on the x and y intercepts, what I'm going to do is to find the x-intercepts is where the numerator equals 0. Well, you can't take -5 equals 0 because it doesn't equal 0. And furthermore, if you look at the graph, it looks like it's not crossing the x-axis, so there is no x-intercept. And for the y-intercepts, you want to find f of 0, which means you substitute in. If I come over here and hit trace, and then automatically what pops up, we get 1.25, because that's where x is 0. You're going to see it trace is 0, enter, and you'll see it that way also, 1.25. So what you can do is go to 1.25 and hit math, enter, enter, and you'll see a y-intercept of 0.5. Anytime you hit trace, it starts with the y-intercept. Got that? Where it crosses the y-axis. That's where its trace starts. So that's kind of a really neat and easy way to do that. For the horizontal asymptote, if there is one, we look at the degree, which is exponents. So let's see, we have -5 over x minus 4 as a function. Degree means exponent in the numerator. Since there's no x value, it's a constant, so it's 0, because that's like -5x to 0 power. Then here the x has an exponent of 1, so that's the degree of the denominator. Since 0 is less than 1, the top is less than the bottom. That means y equals 0 is the horizontal asymptote, which also means that we do not have an oblique asymptote. For it to have an oblique, the numerator has to be greater than the denominator by 1 value. So now we're going to put all this together and we're going to graph it, which we already know what the graph looks like, because we put it in a graphing calculator. This just helps us. We know we have a y-intercept at 0, 1.25. We know we have a vertical asymptote, 1, 2, 3, 4, at x equals 4. And we know it's up that way and that way. So let's just go ahead and draw the graph. It approaches, well, we also know that y equals 0, the x-axis, is an asymptote. So we're going to approach, and we're going to cut through and go up, something like that. It's actually approaching. That's what it means to be an asymptote. Then approaches and approaches. And there's your graph.